Hi everybody, welcome to the Manifold channel. Today we're going to continue our series in the on the wonderful new join dialog, and we're going to take a look at how we can do joins from vectors to rasters, that is from drawings to images. And we're going to use this map that you see here in front of us. We're looking at Manifold System Release 9, and you can do all this in the free viewer as well. So if you want to download viewer and follow along, you can do this as well. And this is going to follow along in the example, which is in the new editing and combining data section of the user manual under the join dialog. That's this collection of join examples there, and this follows along with one of them. What we're going to do is we have this map here where we have a terrain, and the terrain is this a component called terrain, which is just simply this image right here, and that image is full of tiles, and each pixel in the tile has a terrain elevation value for this terrain. And the terrain shows a terrain elevation. It's a single channel image with just channel 0. This shows terrain elevation in the region of Livermore, California. And then on top of that, we have this vector layer, a drawing called overlapping parcels, and that simply is full of these rhomboid shapes, which we call parcels for no other reason other than that's a good name for them. And the overlapping parcels drawing has basically, besides the index field and the geometry field, it has a single z attribute field, which gives a z value that's been picked pretty much by hand manually to be somewhat above the prevailing the average terrain elevation in the region of that rhomboid. And then in addition to that, we have a labels layer, which simply gives us the z value for each of these rhomboids, so we can keep track of that. What we're going to do is we're going to transfer the z value from each of these rhomboids into the pixels that are underneath it. So the elevation of the pixels in the terrain image that are underneath, that are contained within each of these rhomboids, will be the value that's the z value in the rhomboid. And that also means we have to figure out what to do in these regions where two parcels overlap, because they're all not separate. Some of them overlap. For example, right here and right here, there's some of them overlap. So let's get right to it. With the focus on the terrain layer, we're going to choose Edit, Join. And in the Join dialog, on the left here is the destination, the so-called original image or table or drawing or whatever. And here is the whatever we're joining into it. So we're going to pick overlapping parcels as the join drawing. And the relationship that we're going to use to match the two is that we want to get all pixels that are in the tile that are contained within objects in the geometry of this drawing. And all that's going to go into channel 0. So, wait a minute. Before I do this, I want to be able to restore all this. So let's make a backup of this terrain, because we're actually going to be changing this image. So let's copy that, and let's paste to make that. And let's call this, let's give this a name, and rename related. Let's call this backup terrain. I love this, rename related, because it renames everything all at once for you. Okay, so now we have a copy of that terrain. So now we can peacefully work with the terrain, and if we want to restore it to what it was, we can restore it from this backup. Okay, so once again, with the focus on the terrain in the map, we can click Edit, Join, and once again we're going to choose overlapping parcels. We want to take the data from the overlapping parcels and put it into the whatever tile pixels, all the tile pixels that are contained in the various objects that are set forth by the geometry and the overlapping parcels. We're going to put all that into channel 0. So we're going to double click here for the source into this cell right here. Double click that and choose Z. And now we got to decide how we want to aggregate what's coming in. We have several choices here. For example, we can do count, max, min, or sum. Now, what's all that about? If you look at this region of pixels right here where these two rhomboids overlap, this region of pixels, for every pixel in here in this overlapping region, there's two areas. Those pixels are contained in two areas. So which value should we take? Should we take 550? Should we take 450? Or something else? And Manifold gives us 4 options by default. There's count. In other words, you can count how many areas overlap. So that's not particularly interesting. Count for all the regions here would be, pixels here would be 2. Sometimes that's convenient to see how many overlapping objects there are for each region. Sometimes it's not. Max simply gives us the maximum. So for the region here, the maximum of the two values would be 550. So all these pixels here, we get the value of 550. Minimum takes the minimum of the two overlapping areas. In this case, that would be 450. So all the pixels here would get 450 as the minimum. Sum, which is what we're going to use, takes the value of all the various overlapping areas and sums it. In this case, there's only 2 areas that are overlapping, so that would be the sum of 550 and 450, or 1,000. Let's pick that. Now, before I do that, if you look down here at this single area where there's no overlaps, it doesn't matter what you choose between maximum, minimum, and sum, because the maximum of 650 is 650, the minimum of 650 is 650, and the sum of 650 plus nothing else, because there's only one area there, is also 650. So if you're working with areas that never overlap, you can use maximum, minimum, or sum. It doesn't really matter. In this case, we're going to use sum so that the overlapping areas produce a rhomboid here with a value of 1,000, and that'll give us a nice visual difference. Great. Now that we've explained how all this works, actually using join dialog is just one click. You click join component, and it's done. And what it did is it took all the different values that are in these various rhomboidal areas, and it put them into the terrain. If we turn off overlapping parcels, we can see how that works. The terrain actually here has been modified. The image has been modified. So what we're looking at here is it is as if in this region here, suddenly the terrain moved up, and there's a rhomboid-shaped plateau with a height of 300. And right here, it's as if there's a rhomboid-shaped plateau that kind of has jutted up from the terrain with a height of 650, and likewise here for 500. And here, in the regions of overlap, they're slightly different. We don't have labels on those because the labels come from the vector drawing. But if we want to see what those look like, we can turn on contents, and in the contents go to style, and you can see here's the thematic format used. So you can see how these different regions, for example 350, that's kind of right in the range here, how they're colored differently based on height. If you want to bring out the color difference from this one here, that's at 1,000, and the thematic format for terrain ended at 660 because that was the highest value before we started messing around with join. So let's add a new interval, 1,000. I just clicked in there to add that, and now I'm going to double click into here to change that color to a bright magenta, click update style, and you can see how that thematic format is now being applied to this region right there. Everything here in the terrain has changed. If I go into the options and I turn off shading, you can see, click update style, you can see how all the different pixels here are colored by that thematic format, and these pixels here genuinely have been changed in the terrain. Let's turn the shading back on. If I recall my Z value as 0.3, click update style, and so now we have that terrain again presented with those images. Now suppose I want to restore this. I didn't want to make such a permanent change to it. I mean, I did make a permanent change. That's pretty easy to do because I had the sense to make a copy of the terrain image, and notice that I copied both the terrain and the tiles for the terrain as well. So what I'm going to do is I'm going to drag and drop this backup terrain into there. And the first time it appears, Manifold warns us that we need to rebuild intermediate levels, so let's do that. All right, so you can see the backup terrain is the way the terrain originally was, the image originally was. What I will do with the focus on terrain, I'm going to use the join dialog to restore values in the join dialog. I'm going to take them from the backup the terrain image. So what we're going to do is an image-to-image join. And here we go. The joined data is going to be this backup terrain. We're going to join data from the backup terrain image into the terrain image. And what I will do is I want to take data from channel 0 in the backup terrain image and copy it into channel 0 into the terrain image. Now the moment I click join component, it's going to do that join, which basically takes the data from this backup and restores it, and it copies that into the terrain image into channel 0. Super. Now suppose instead of altering things in channel 0, which is what we did with the default use of the join dialog, we wanted to add a new channel to the terrain image. So instead of it being a one-channel image, this guy right here, we want to make it a two-channel image. If we look at the component here, you can see, we can see that this is a float 32, and it's basically that's the data type, which indicates it's a one-channel image, because otherwise it'd be float 32 x2 or x4 or whatever for the number of channels. Let's do that right now. Let's take this join, and instead of joining into the terrain image, we will join into the terrain image into a second channel that the join dialog will automatically create for us. With the focus on the terrain layer, once again we click Edit, Join, and once again we're going to join data from the overlapping parcels layer. And instead of double-clicking here to pick a field, what we'll do is we will click here on the Add button, and the Add button gives us a list of fields that we can take data from the overlapping parcels drawing. We'll choose the Z field, and it automatically sets it up so it's going to add a new channel called channel 1, which is going to be with data taken from the Z field, and we'll change this from count to sum. Okay, so now when I click join component, it's going to add a new channel to the terrain image. And let's work with that new channel. Let's see. Let's format that. And there's a variety of ways of formatting it. One of the easiest ways of doing that is to take the terrain image, not the table, but just the image, copy that, and let's paste that as a terrain image called terrain 2, and let's rename this to second terrain channel 1. Notice this is zero-based numbering, so the first channel is channel 0, the second channel is channel 1. And now let's drag and drop that into this map, and you can see there's no difference between, I'll turn off overlapping parcels also. You can see there's no difference between terrain channel 1 and terrain channel 2, turning this off and on. It's identically the same as terrain. Why? Because for now, it still uses channel 0. In fact, if we want to look at the style format for it, you can see it's still using channel 0. That's the style format there. So what we're going to do is we're going to change this so that, and this is kind of a cheat, this is an easy way of doing it, we're going to change this so instead of using channel 0, I'll right click and choose edit, it chooses channel 1. And styles and manifold are just these JSON strings. That's all it is. So you can alter them, to your heart's content, and it's very easy to do. And changing this in the properties dialog instead of in the style dialog is a way of retaining all this other thematic formatting without having that reset when we change the channel. So everything else, like the sun altitude and all the rest that we're using for shading, all that's going to stay the same. So we're going to change the channel 1, click OK again, and there. Now you can see what channel 1 looks like. This terrain image here, if we right click on terrain, that is still being formatted based on channel 0. Terrain channel 1 is now being formatted based on channel 1. Both of them are taking their data from the terrain tiles table. Let's now change style for terrain channel 1, and if I click here at content style, let's mess around with that a bit. And you can see here's the 0 thing. Now the lowest value, why is all this stuff green? Because all these pixels are basically have a value of 0 now. And that's because when we did the join, there was no overlapping areas into those. If I want to knock those out, I can change this value right here to transparent, and that'll make transparent everything at 144 and below. Click Update Style, and if you turn off that terrain, now we're looking at just the terrain channel 1. You can see, in fact, it's in the layers. Let's turn off the background. You can see that terrain channel 1 is now an image where all the pixels are transparent except those which were brought in from the overlapping parcels layer. Back here in if I want to turn on the terrain, you can see we're now looking at the data which is in the terrain tiles table, and we're looking at it using two different images. An image in manifold is nothing but, if I look at the properties, it doesn't actually have any data in it. All it has is it says what table to take data from and what to use as the tile field, and this little JSON string that says how to style it. That's all an image is. So when we copy and paste an image, we're not actually copying and pasting the actual table. We're just copying a little description of how to show that table. So when we copied this and pasted it to make another image, that other image is still taking its data from the same table. So this particular image, though, has been styled so that it takes its data from channel 1, and this particular image has been styled so it takes its data from channel 0. In fact, if we look at the style dialog for the two, we can see with the focus on the terrain, it says channel 0. With the focus on channel 1, it says channel 1. That gives us the ability to show data from the same table from two different channels at the same time in two different ways and two different layers, which can be styled completely differently. We can apply a different thematic format to this one, and we can do things like, for example, here in the style dialog for channel 1, we can turn off shading. And that's only going to turn off shading for this layer. It's not going to turn off shading for the layer for this terrain layer underneath it. I hope you've enjoyed seeing how all this works. This is kind of the second thing. What we did here is a little bit more sophisticated, where we took data and put it into a separate channel. That allows us to play around with the image in different ways. If you look at the component here, you can see the image now that we're working with, whether it's terrain or terrain channel 1, now shows that it's float 32 times x2. That means there's two channels in it. So we really have added a new channel to that raster image. That shows part of the power of the terrain, the drawing dialog. It can not only update data within a particular channel for an image taken from a raster, it can also create a new channel. In fact, it can take data from the image itself and create it to a new channel. If you wanted to make a copy of the image of itself and have a copy of that in the channel instead of making it in the backup. we'll show how to do that in a different dialog, in a different video, because this one also already has run a little bit long. I hope you can see the power of the drawing dialog. Things which used to require sort of specialized ad hoc dialogues, for example, to convert a vector to a raster or whatever, can now be done in the middle of drawing, because really what all this stuff is it's just a join. It's one massively cool concept that applies in many different ways. But once you get your head around that single concept of a join, you can see that you apply the same thing over and over with exactly the same user interface. For example, it's all this join dialog, and whether you pick a drawing here or an image or a table, whatever it is that you're doing, it's still the same idea, same kind of notion of being a join. I hope you've enjoyed this video. Thanks for watching. Remember, to learn more about these, what you see here, you can go into the user manual. The user manual covers all the stuff in depth with lots and lots of, hundreds of examples, point-and-click examples that are lavishly illustrated step by step, so you can drill into whatever detail that you want to see here in greater detail in the user manual. Again, thanks for watching, and goodbye from Manifold Land. Well, that was fun. If you want to see more, visit us at www.manifold.net. As always, Manifold delivers the world's most advanced, highest quality spatial products for GIS and DBMS at a low price that you can afford. Once again, that's manifold.net. See you soon.